So before we dig into summary questions 5 and 6 here, I just wanted to hit you up with my analogy of open versus closed systems. Thinking about it like it's a gas station, right? On one hand, the gas station can be closed for business. On the other hand, the gas station can be open for business. And during those times of open versus closed, we see different things happening with matter. Remember, that's the stuff going in and out of the gas station, and then also energy. We're talking about like light energy or heat energy going in and out of the gas station. So this is our analogy that we can apply then to any open or closed system. So in a closed system, what we notice about matter or stuff like atoms and particles is it cannot enter and leave. Right? Think about that gas station with the door closed and locked up. We're not going to see people, which is matter, going in and out. We're not going to see them going in, handing money, and then coming out with Cheetos and Mountain Dew, right? We're seeing that matter is fixed. It's unchanging during the closed or within a closed system. In terms of energy, though, we do see some enter and leave. And that's because that light and that heat can go in and out even though the door is closed and locked in our gas station analogy. Okay? Small amounts of light can get in, small amounts of heat can get in and out even within a closed system. So our keyword kind of here is some, right? Small amounts. Now when we think about the gas station being open, now the door is open for business. I do see people coming in and out with Mountain Dew and Takis and hot dogs and donuts and whatever other goods they're getting from the gas station. So we do see enter and leave for matter. So can enter and leave. It's not fixed anymore, but it is changing. And then in terms of energy, we see that it can enter and leave freely. So we get a higher amount of energy transfer. So again, the door is open, more heat is going to go in and out as that door gets opened. Light can still go in and out through the windows. Maybe the lights are on in the gas station, so we're getting more light energy as well. So we're really thinking about what this material is doing when a system is open versus closed. So thinking about closed being like that locked gas station, our amount is fixed. We can't have stuff going in and out, but some energy can still pass through. Whereas when the system is open, we get a free movement of both material and energy. So I like to use that gas station example as a good kind of analogy, right? So that means when we get down here to our practice problems, we're simply putting those key words into these boxes down here, right? So matter can move in and out or cannot, open versus closed, and then what can the energy do? So because you're doing this in Notability, it should be really easy just to grab your scissors tool and say, okay, which one of these can matter move in and out? Is that the fishbowl here or the terrarium? Right? So looking at the lid options, think about where matter would go, think about where energy would go, and then think about, well, based on those characteristics, is that going to be an open or a closed system? So you should be able just to plug these in wherever they go here. And then finally, this bottom one is thinking about Earth as a closed system. Why is that? And really try to use those keywords that we've been using. What exactly is happening with matter and energy that makes it officially a closed system? Great job.